Excellent. Yes, it's a topic of conversation that we have a lot of questions about now. One, because of energy requirements, the different types of heat, and we'll specifically talk about heating systems because where we live here in the Northwest, again, we heat our houses more than we cool our houses. But we will touch on the cooling side of a system, basically from the aspect of a heat pump and how that actually works. So we're going to be talking about that as well. But first I want to address, and we're primarily at this point, we're going to talk about gas. And we're going to talk about gas furnaces. There are several types of furnaces. We have gas, we have oil, and we have electric. And so we're going to talk about all three of those. But in particular, probably because what I've seen, I'd say the majority of the homes have gas furnaces. So we always want to know, we've heard stuff about high efficiency and really what makes up a high efficiency type of furnace. So the first thing I will say is that there's efficiencies range from 80% actually all the way up to 96% efficiency furnaces now. So what makes up a high efficiency furnace? A lot of times when you're driving down the road or maybe even at your own home, you'll see on the roof line where there is a metal vent pipe coming out of the roof, and that's your exhaust for, typically it's your furnace, although if you have a gas hot water tank, those two appliances could be tied in together and they're using that one vent on the roof. That vent is referred to as a B, as in Bravo, a B vent. Typically it's a double-walled vent, and it's because of the temperature of the exhaust gases that are being given off by your gas furnace. Typical vent like that would indicate that you have an 80% efficiency furnace, which is not as high as 96 naturally. So what makes up the efficiency rating? Moisture holds heat extremely well. As an energy auditor and also as an infrared camera specialist, we deal a lot in heat transfer and how those types of things work. But water holds its heat extremely well. It is the last thing called emissivity. It's the last thing to emit emissivity, the emit its heat from a substance, whether it's from a roof or anything else, boiling water, etc. Well, an 80% efficiency furnace has a lot of moisture that is released because of the gas as it burns and combusts inside of there. So a lot of times you'll see the B vents on the roofs actually looking almost like a steam pipe, right? A lot of steam coming out of there. Well, as we all know, steam and moisture, that's a lot of heat. It'd be like putting your hand over a pot of water that you're cooking on the stove. The steam will burn you to a first-degree burn at least. The heat that's being emitted, that's a lot of heat that's being lost that we could actually recover in a system. The measurement of temperature in Fahrenheit of the heat being lost out of a non-high efficiency furnace, we'll call it an 80%er, basically that temperature will range anywhere from 375 degrees to 425 degrees that's being emitted out of that pipe. That's a lot of heat. A high efficiency furnace, although basically the componentry of that, it extracts the water vapor off of the exhaust gas vapor before it discharges. So now therefore that exhaust temperature is only anywhere between 70 and 90 degrees Fahrenheit. So without doing the math, that's roughly, let's say, about 300 degrees of Fahrenheit temperature that we're actually recapturing before it gets exhaust out of the stack. You'll see on a high efficiency furnace we're actually using piping, which is like plastic tubing, okay? So we'll have two pipes. Typically what we like to see is two pipes, although there are sometimes where there's only been one pipe, and I'll address that. But the two pipe situation, one pipe is actually exhausting air, and the other is actually pulling air back into the furnace, so it's getting its fresh combustion air from the outside of the house to bring back into the exchange mechanism in the furnace to heat that air and distribute that heated air throughout the house. So typically on a high efficiency furnace, you'll see two plastic pipes. They could come out the roof, they could come out the side of the house, or they could come out, in other different areas, but typically the roof or the side of the house. So therefore, you'll know right away if you're looking at a house, you're out there purchasing a house, and you see there's the metal vent pipe coming out of the roof, that's actually a 80% efficiency furnace. If you see the plastic vents, those are actually a 90, 95, 96% efficiency furnaces. There are rebates also that are being given for high efficiency types of appliances, and the furnace is probably one of the biggest aspects that we look at in the house. A high efficiency furnace has no real theoretical demand on where it gets its fresh combustion air from. Now, one thing that we have to be aware of is that we want to draw our air typically from the exterior of the house. So what I mean by where it gets its air from, a high efficiency furnace can be placed theoretically just about any place in your home. It could be in the garage, it could be in a closet. So the areas in which it can be installed allow you greater flexibility in which to place that unit. If you have an 80% efficiency furnace, typically we see those in garages because the garage is what we refer to again as a unconditioned space. It is not heated on all 6 sides. It's not designed to be heated on all 6 sides. It is a garage. It could in essence be an unconditioned space or a semi-conditioned space. But for the most part, garages are unconditioned spaces. So as a homeowner looks at the square footage of a house, it's interesting to know that this garage square footage is never included in the house square footage because the house square footage is based on the conditioned space. So now because of that, the sizing of a furnace is very important. It's not, again, the square footage of a house. Okay, you have a 2,100 square foot home, but you may have an excessive volume of air, the length times the width times the height. The conditioned space within the house is what you're trying to heat or cool the air. So when you have a new furnace installed, or you're purchasing a home, or you're, let's say, buying a new home and they're putting the furnace in, that furnace is going to be sized according for the volume of air that's actually moving throughout the house. So it's very important to understand that. The benefit of a high efficiency furnace is you're recapturing a lot of heat that would be lost out the stack. It has no theoretical application on where the furnace is actually placed, simply because of the air intake. We always want to have the exhaust, although going to the exterior of the house naturally. The situation sometimes that I run into as an inspector, is that I will get on a property inspection and I'll see that the air intake pipe for the intake to the furnace is not getting its air from the exterior of the house. I'll see the furnace in the garage, and therefore the pipe is actually drawing its air from the garage. Well, garages are what I refer to as notorious fire zones. Paints, thinners, gas, automobiles, lawnmowers, combustible types of products are stored in the garages. It's not always the combustion issue that I'm concerned about. It's the indoor air quality. The paints, the thinners, the gas, the lawnmowers, all the things that contain noxious and toxic fumes are also stored in your garage. So if you are taking your air that you're using to heat and you're drawing the majority of that from a garage, for example, that's the air that you're heating and disseminating throughout the house. So therefore, it's basically taking all those fumes and it's diluting it, parts per million that is coming into the house, but it's also going to affect your health. If a furnace is located in an attic or a furnace is located in the crawl space and it's getting its fresh/combustion air from those areas as well, those typically aren't good areas to draw air from either, although an attic is probably a better area than what a crawl space is by most certainty. So anytime I see those situations, I'll always make recommendations for the homeowners to check with a professional HVAC contractor, heating contractor, to make sure that we're getting our fresh/combustion air from a good place and not from specifically garages or crawl space areas.